Okay, this question says, in a large university, the probability that a student is left-handed is 0.08. It says a sample of 150 students is randomly selected from the university. Let K be the expected number of left-handed students in this sample. And then it asks us to find K. So we need the expected number. Now the way we do this is the probability of finding an individual left-handed student is 0.08. So any one we find will be 0.08, and since there's 150 students in our sample, we would just need to multiply the probability of finding one by the number that we have. So we need to do 150 multiplied by 0.08, which is going to give me 12. So K is equal to 12. Okay, next it says, hence find the probability that exactly K students are left-handed. So the way we're going to do this, we're going to look at the probability the student is left-handed, which is 0.08. Then we're going to need the probability that they're right-handed, or not left-handed, which is going to be 1 minus 0.08, which is going to be 0.92. Now, if I wanted to get 12 students that were left-handed, I would need to multiply the probability of finding one left-handed one by the probability of finding a left-handed one again by the probability of finding left-handed again up to 12 times. So I would need to do 0.08 to the power of 12. Once I'd selected my 12 left-handed students, I would then need to select 138 right-handed students, because there's 150 altogether. After I've selected 12 left-handed students, I'd need to find 138 right-handed students, and then so the probability of finding them both would then be 0.92 to the power of 138. Now that would be the probability of first of all selecting 12 left-handed students and then afterwards selecting 138 right-handed students. Now to get the total answer, I'm going to need to multiply that by the different permutations and different orders I can do that in. So there's a way of doing that is the NCR, so it's going to be 150 and then NCR 12, because there's going to be 150 total, 12 different things, and there'll be many combinations for working that out. So what I've done here is basically reproduce the formula which is on your data sheet. This formula here, it says this one, 5.8 binomial distribution, and it's got the probability of x events is nr and then p to the power of r, 1 minus p to the n minus r. So my n is 150, my r is the 12, p is the 0.08 to the power of 12, and then 1 minus 0.08 was my 0.92 to the power of 150 minus 12, which was my 138. So you can copy the formula from here. Probably you can also just use your graphical calculator and put it in, and it would work out what that was. Now instead of doing that, what I've done is I've written that into a spreadsheet. So I've got my number of events here, which is 150, probability of a single event, which is 0.08, and then the number that I want to find, and I've entered the formula I was talking about there, and that's given me the binomial expansion for 12, or binomial distribution would be 0.119. So I'm going to round that to 0.12. So here this is 0.112. Alright, now what I need to do next is that fewer than K students are left-handed. So the way that we do this is we do the same thing here for because we've got to have fewer than 12. I could have either 0 students or 1 student or 2 students, 3 students up to 11. So what I'd do is I'd use the same thing, but I'd first of all do it with 0 here and 150 here and 0 here, and then I do it with 1 here and 149 here and 1 here, and so on. So I've gone back to my spreadsheet again. So what I've done here is enter it in for 11, then 10, then 9, 8, 7, all the way down to 0, and then I've summed up all of these here. So we add all of these individual probabilities together, which has given me the answer here, 0.457. So this one, part 2, is 0.457. Now you can also use cumulative distribution function calculator. So what I've done here is cumulative distribution function, which you'll have on your graphical calculator also. You'd enter the probability of success, which is 0.08, the number of successes you need, which would be up to 11, so that would include 0, 1, 2, 3, 4, 5, all the way up to 11, and the number of trials, which would be the number of students. Calculate that, and that's given me the exact same answer. The way this calculation is done is like I've done it on the spreadsheet, just to show you where that comes from. So I've got the same answer, 0.456 or 0.457. This answer here. The following diagram shows the chord AB in a circle of radius 8 centimeters, where AB is 12 centimeters. We've got a diagram here. So the chord is this one here, and then it's asking us to find the area of the shaded segment. So we need to work out the area of this. So the way I'm going to do this, I'm going to just add on a couple of extra parts to the diagram. So I'm going to draw in 2 radii there. So this is meant to be the center of the circle. This is the radius. So since it says the radius of the circle is 8, this will be 8 centimeters here. Likewise, this will also be 8. Now, the plan is going to work out the area of this sector here, and then I'm going to work out the area of this triangle, and then do the area of the sector, subtract the area of the triangle, which will give me the shaded area here. So, in order to do this, I'm going to need to know what this angle is here. So I'm going to call that theta, and then we're going to need to work that out. So the way I'm going to work that out is I'm going to do right angle triangle half the size of this. So the right angle triangle will be like so. This will be a right angle here. This side will be 8, this side will be 6, and then this angle here will be half of this angle here. So for this angle here, I can say that sine of the angle, so that means I'd need to do inverse sine of then 6 over 8. So then that would mean that theta would equal 2 lots of inverse sine, and then 6 over 8 I could simplify to be 3 over 4. Alright, so that would tell me how I could work out this angle. Then, in order to work out the area of the sector is equal to 1/2 r squared theta, when theta is in radians. So I can work what that is. So that means the area of the sector will equal 1/2 times 8 squared, and then times the angle, which is 2 sine to minus 1 of 3 over 4. So using my calculator, I need to make sure I'm in radians mode, so change to radians, and then do 3 over 4, inverse sine of that, times that by 2, times that by 64, and then divide that by 2. So I can say that would be 54.3. Okay, what I'm going to do next is to work out the area of the triangle. Now I'm going to use the area of the triangle formula, which is 1/2 AB sine C. So the area of the triangle is equal to 1/2 AB sine C. A and B are 2 sides, and then C is the angle in between. So it's going to be the sine of this. So since I know that the sine of this is inverse sine would be 3/4, so the sine is going to be, I'd have to do the sine of that angle there. I guess I could work out the area of this one, do this sine, so I know that would be 3/4, and then do 8, no, because I don't know that side. Okay, I'm going to have to work out what this angle is and then do it like that. So I'm going to say area of the triangle is going to be 1/2 times 8 times 8, and then times the sine of 2 inverse sine 3 over 4. Okay, so I can work out what that is. So if I do the angle, so start with 3 divided by 4, inverse sine that, times that by 2, and then do the sine of that, then times that by 8, and then divide by 2. That's going to give me 31.7. So then that would mean that the shaded area is going to equal 54.3 minus 31.7, which is going to be, that's going to be 0.6 to 22.6.